This video is all about sketching gradient functions. If we're sketching a gradient function, what we are doing is we are putting the gradient of the curve on the y-axis rather than the y-coordinates. If we know what the function is, in this example I know the function is x squared minus 3x. If I want to sketch the gradient function, I could just differentiate to get the gradient function. So differentiating the x squared, we get 2x. Differentiating the minus 3x, I'll get minus 3. And I know that that's got a gradient, a y-intercept rather, of minus 3. It's got a gradient of 2. So it's going to look something like this. It's going to intersect here when this is going to equal 0. So x would be 3 over 2 or 1.5. So what I'm doing here is I'm saying that the gradient is 0 when x is 1.5. Which hopefully makes sense from our sketch over here, that we've got a turning point. We've got a stationary point when x is 1.5 over there. So the gradient would be 0 there. And then to the left of that point over here, we can see that the gradient here is negative. It's a decreasing function. Our gradient is negative to the left. And to the right of that point over here, the gradient is positive. It's an increasing function. It's going up. So our gradient is positive over there. So we're going to talk more about that in a few moments. This video is now going to be more about how we can do this process, how we can sketch gradient functions if we don't actually know what the function is, so we don't have actually anything to differentiate and draw if we've just got the original curve itself without the function. So to help me explain this, I've got an app here on GeoGebra. We have got the curve, a quadratic curve given there, and we can see that a tangent's being drawn at different points on here just to help me demonstrate what the gradient is going to be at different points. So for example, when x is minus 2 there, the gradient at that point there is minus 3. I know it's minus 3 because if I go along 1 square in the x direction there, I go down 1, 2, 3, so the gradient there is minus 3. So my gradient function is going to go through the point minus 2, minus 3. And you can see that point has now been plotted onto this graph. As I move along the curve, you can see how the app is drawing on the gradient function for me. When I get to the point when x is minus 1, again the gradient, if I go along 1 square here, I'm going down 1, 2, so the gradient is minus 2. As I keep moving along, you can see how the gradient function is looking. When I get to that point there, when x is 0, the gradient is, when I go along 1 square, I go down 1 square, so the gradient is minus 1. So this app is showing what the gradient is as I move along the curve. Notice when I get to this stationary point here, the gradient is 0. Now, we've got a stationary point here. So my gradient function is going through the x-axis because the gradient is 0 at this point. And now the gradient is positive, so now my gradient function is above the x-axis. It's an increasing function now. So, where we had the turning point, when the gradient was 0, my gradient function is crossing the x-axis at 0. Where the curve was decreasing, where the gradient was negative, my gradient function is below the x-axis. Where the gradient function is, where the original function is increasing, where the gradient is positive, my gradient function is above the x-axis. So that's an example of a quadratic one. Let's have a look at a cubic one now. So here I've got the x cubed minus 3x squared plus 2x function. And again, I've got the tangent here to help me demonstrate what the gradient's going to be. So to begin with, we've got a positive gradient here. And as I move along here, the gradient is becoming less positive. You see how the tangent, the blue line, is becoming less steep. It's becoming less steep. It's becoming less positive. It's getting flatter. The gradient's going down, down, down. When I get to this point here, the stationary point, notice how the gradient function is crossing the x-axis now because the gradient is 0 at that point. And now my gradient's becoming negative because the blue line's going down. It's becoming more negative. When we get to this point here, it stops becoming more negative and starts becoming less negative. The gradient's still negative, but it stopped increasing in a negative way and it's starting to go up again now. We'll talk more about this point here in year 13. This point is called a point of inflection, where the gradient stops decreasing and starts increasing. But don't worry about too much about that for now. The point is the gradient is still negative at this point, still negative. But when I get to this turning point, the gradient is 0 again. So my gradient function is crossing the x-axis again. And now the gradient's positive, getting bigger, more steep. And there we go. That is what the gradient function looks like for that cubic. Again, just highlighting the key points here. The gradient is 0 at the turning point here, which is why it crosses the x-axis there. We've got another turning point here, which is why, again, the gradient function crosses the x-axis here. The gradient, this part of the graph, the gradient was positive because it's increasing there. So this part of the graph, the gradient function was above the x-axis. The gradient was negative in between the two stationary points there, which is why my gradient function's below the x-axis between those 2 points. And then the gradient is positive all the way over here. It's increasing all the way over there, which is why my gradient function is above the x-axis there. So let's have a look at what this might look like for you guys in your A-level. 3 examples. In each case, we're going to look at where the turning points are, first of all, because that's going to tell me what the gradient is, when the gradient is 0. So for the first example, we've got the turning point at minus 2, 3. So I know the gradient is 0 there. So straight away, I'm going to put on my gradient function that the gradient is equal to 0 at that point. To the left of that point, I can see that my gradient is positive. Positive. The gradient, the tangent is getting less positive though as we go on. It's getting less steep. So the gradient's becoming less positive, but it is still positive for all of those values to the left. So when I'm drawing my gradient function, it is positive, but it's going down. So it's positive for all of these values here. And then after the stationary point, the gradient is always negative, and it's getting more negative. So my gradient function will continue down here, showing that the gradient is negative for all of those values there. And that's it. That's the gradient function for that first curve. Notice that the original curve here looks like a quadratic, and my gradient function looks like a straight line, because when you differentiate a quadratic, you get a straight line, or you get a linear function. Second example, we've got a turning point when x is minus 3, so straight away minus 3 on my x-axis here, that my gradient function will cross through the x-axis there because the gradient is 0 at a stationary point. We've got another stationary point here when x is 2. So again, I'm going to put an intercept on my x-axis there because the gradient will also be 0 at that point. Right, then over here we've got a positive gradient, positive gradient, positive gradient. But it's becoming less positive. So we've got positive, 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 getting less positive as we go on. So that's that part of the graph. In between the two stationary points, the gradient in between them was negative. Negative gradient in between there. So it's going to be, on my gradient function, I need to show that the gradient is going to be negative in between those two stationary points. And then after the second stationary point, the gradient is positive again. So my gradient function should be positive again. Again, talking about the shapes of these graphs, this looks a little bit like a cubic. This looks a little bit like a quadratic, which should make sense because when you differentiate a cubic, you should get a quadratic. And the third example, we've got this quartic looking graph here. We can see we've got a stationary point at x equals -3. So let me put that straight away here. We've got another stationary point when x is 0. So let me put that here. And we've got another stationary point here when x is 4. So let me put that there. So the gradient is 0 at all of those points, and my gradient function should cross the x-axis at all of those points. Then we've got a negative gradient over here. So my gradient function should be negative for all of those values. So negative gradient to the left of -3. Then after the -3, we've got a positive gradient between these 2 points. So my graph should have a positive gradient here in between the -3 and the 0. So we've got a positive gradient between -3 and 0. Then between 0 and 4, we've got a negative gradient again. So my gradient function is going to have a negative gradient in between 0 and 4. And then after 4, we've got a positive gradient again. So that's going to go up here like this. And again, we've got a quartic equation in the first place. This looks like a quartic. When we differentiate a cubic, which is what this looks like here, so that makes sense. So there we go, that is how we draw a gradient function. You look to see where the stationary points are, that's what tells you the intercepts. And then you think about whether the gradient should be positive or negative either side of that.